In section 3.1, we're going to look at polynomial functions, quadratic functions, some graphing techniques, revisit completing the square, the vertex formula, and some quadratic models, which means word problems. A polynomial function of degree n is written in this form: f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 all the way to a sub 1 x plus a sub 0. Now essentially this is a string of terms, and the terms are connected by leading coefficients between each of the terms, and the exponent is just a natural number, a non-negative number. We have different types of polynomial functions. The simplest one is a constant function. It has degree 0 because the exponent is 0. There's an invisible x to the 0 next to the constant number 2, so this has a degree of 0. The leading coefficient is always the number in front of the highest power. In this case, we just have a 2. The second function is a linear function, and we know the standard form for a linear function is mx plus b. The leading coefficient is at 5, and the exponent is a 1, so the degree is 1. The third function has a leading coefficient of 4. It is a quadratic function because we have a power of 2, and therefore the degree is 2. The fourth function is a cubic function. It has a power of 3, so the degree is 3. The leading coefficient is 2. The last one is a quartic because the power is a 4. The leading coefficient is a 1 because there's an invisible coefficient of 1 in front of that x to the 4th power. A quadratic function is of the form ax squared plus bx plus c. And this is a quadratic form because we have the power of 2 that it shows up as the exponent. The a is a powerful number. It controls whether the quadratic faces up or faces down. The simplest quadratic function is f of x equals x squared. We are going to call this our parent graph because it's the simplest quadratic you can have. So let's make a table. We'll say -2, -1, 0, 1, 2 for the left side, and these are the x values I'm going to pick. You could pick whatever values you want, but this is a good starting point because these are easy numbers to calculate. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and finally 2 squared is 4. Now if I plot these points, I will get that nice parabola that I'm looking for. The domain, remember, is how far left the graph goes to how far right. And in this case, the graph goes forever towards the left side, and it goes forever towards the right side. So the domain is -infinity to infinity. The range is different. It stops at 0, so it doesn't go below 0. And it goes up forever, so the range is 0 to infinity. Parabolas are symmetric with respect to a line. This line is known as the axis of symmetry, or the axis of the parabola. Now, if a is greater than 0, the leading coefficient, we're going to have a parabola that faces up. If a is less than 0, we're going to have a parabola that faces down. The axis of symmetry, remember, is a mirror reflection on the other side. So if there's a point here, it's automatically reflected on the other side at the same distance from the axis of symmetry. Compared to the basic graph of f of x equals x squared, or our parent graph, the graph of f of x equals a times the quantity x minus h squared plus k has the following characteristics. The a here controls if it faces up or down. If a is greater than 0, it opens up. If a is less than 0, it opens down. If a is a number that's bigger than 1, we're going to get the graph is going to stretch vertically. If a is between 0 and 1, it's going to get wider. It's going to be stretched horizontally or vertically shrunk. The h here controls the shifting. H goes to the right if this is a positive number. and it goes to the left if h is a negative number. K controls the vertical shift. If k is positive, the graph goes up. If k is negative, the graph goes down. Let's graph the following function, f of x equals x squared minus 4x minus 2. And we're going to do this by plotting points. Here I have the point negative 1, 0, 1, 2, 3, 4. And again, you can pick any points that you want. Just make sure you pick points that are easy to calculate. So let's plug these values into a calculator. Negative 1 squared minus 4 times negative 1 minus 2. I will get the value of 3 when using a calculator. And if I plug in 0, 0 squared minus 4 times 0 minus 2 gives us a value of negative 2. And we can repeat the process with a calculator. Continuing the process, I have the next one is a negative 5. And 2 squared minus 4 times 2 minus 2 is going to yield negative 6. 3 squared minus 4 times 3 minus 2 yields negative 5. 4 squared minus 4 times 4 minus 2 yields negative 2. And finally, 5 squared minus 4 times 5 minus 2 yields 3. So we can plot these points on a graph now. And we get the following parabola. I noticed that the leading coefficient was a 1. And since 1 is greater than 0, we know the parabola was supposed to face up. And it does face up. The range is going to be from negative 6, because it goes down to negative 6. And it goes up forever, so the range is from negative 6 to infinity. Notice that the 6 or negative 6 is included with a square bracket because it touches negative 6. The domain is negative infinity to infinity. It goes left forever and right forever. In part B, we want to graph g of x equal to negative 1/2 x squared and compare that to the original graph y equals x squared and y equals 1/2 x squared. Well, notice some things about the graph. There's a negative leading coefficient in the front. So this is going to drop our graph down. It's going to make it face upside down. The 1/2 is going to tell me that this graph is going to get wider or shrunken vertically. So you can see here, this is the original graph, x squared. And 1/2 x squared, which we can do by plotting points, is shrunken. The third graph here is negative 1/2 x squared. It faces down. In part C, we want to graph f of x equals negative 1/2 times the quantity x minus 4 squared plus 3. Notice that this is our h and this is our k. So the vertex of our parabola is going to be the point 4, 3. So in this case, h is 4 and k is 3, so that's our vertex. We know there's a negative in front of our graph, so it's going to flip it upside down. And you can see here we have plotted negative 1/2 x squared, and we have shifted it to the right 4 and up 3 to our new vertex. Example 2, we want to graph x squared minus 6x plus 7. Find the largest open intervals for which the function is increasing or decreasing. We want to convert x squared minus 6x plus 7 into that nice vertex form. We want to make it so I can read off the vertex h and k. We want to express x squared minus 6x plus 7 in the form x minus h squared plus k by completing the square. This will allow us to read the vertex h and k, and we'll be able to plot it by translation. We'll start by moving the 7 to the right side and looking for this missing number, which we'll use to complete the square. Remember, the formula we need is b divided by 2 squared. So the b in this case is negative 6. So we'll take half of negative 6 and square it. Half of negative 6 is negative 3. Squaring that is 9. So we need that 9 in this place. So we'll add and subtract the 9 because we don't want to change the function value. And then we'll collect like terms. Negative 9 plus 7, we can simplify. And on the left side here, I can use factoring using the diamond method if I like. And then I know the two numbers are negative 3 and negative 3. And we could factor this left side by completing the square. Also, the shortcut is simply to take that b and cut it in half. So I can write x minus 3 because we take negative 6 divided by 2. So our function is now f of x equals x minus 3 squared minus 2. Well, that means the vertex is hk, and so the vertex is 3, negative 2. And our line of symmetry is x equals 3. Now we're going to use symmetry to find additional values. And all I need to do is plot points to find the additional value. I always start the graph by plotting the vertex first. So we'll plot 3, negative 2, and then we'll find an additional value. If I plug in 1, which is really easy to plug in, I get f of 1 equals 1 squared minus 6 times 1 plus 7. And again, I would recommend doing all of this on a calculator, so it's really easy to do. And we get the value of 2. So I can plot the point 1, 2, and then remember we can use symmetry to plot it on the other side. And there you go. This is our parabola. We have the axis of symmetry is x equals 3. Let's discuss where it increases or decreases. If I go from left to right, it looks like it's decreasing, and it stops here at the vertex. So it's going to decrease from negative infinity to 3. So we're looking for the value here. When x is equal to 3, it decreases. So negative infinity to 3. It is going to increase when we start from the x value of 3 all the way to infinity. So it's from 3 to infinity. Example 3, we're going to graph f of x equals negative 3x squared minus 2x plus 1 and identify the intercepts of the graph. I notice that there's a negative 3 in front of my x squared, so automatically I know this is a parabola that faces down. But in order to complete the square, I need to make sure the leading coefficient is 1. So a has to be equal to 1. To complete the square, the coefficient of x squared must be 1. So let's factor that negative 3 to the front, and I'm just going to take that out from the first two terms here. So we have negative 3 times the quantity x squared plus 2/3 x, and we'll leave a space because we're going to put the number here from completing the square. Now, how did this become a 2/3? Well, negative 3 times 2/3, the 3 would cancel out and we would get back to that 2 that we were looking for. So we want to make sure this is the same function that we started off with. So let's complete the square. We'll take the b and divide it by 2 and square it. So this gives us 2/3 divided by 2, which is the same thing as multiplying it by 1/2. We will get that as 1/3. 1/3 squared gives us 1/9. And we could do this with a calculator pretty easily. So that number I need to add is 1/9. And I need to also subtract that 1/9 as well. Now, I need to be extra cautious because as soon as I put this negative 1/9, we need to remember this is in fact a distribution because there's a negative 3 in the front. So we have to remember to account for that negative 3 in the front. So we'll rearrange the function, and we get the negative 3 times negative 1/9 is on the outside now. Remember, it is a consequence of distribution. I'm going to use complete the square on the left side, and I'm going to collect the like terms on the right. This gives us negative 3 times the quantity x plus 1/3 squared. Remember, the shortcut is to take 2/3 and divide it by 2, which gives us that 1/3. So I don't have to use the diamond method and factor it with fractions because it's very difficult to find no numbers. I can just use the shortcut. Take the b, cut it in half, and we'll put it right here as x plus 1/3 squared. And so you can see that our vertex is the point 1/3 comma 4/3. Actually, it's negative 1/3, but since this is a plus sign, we can assume it's actually a double negative. So the vertex is negative 1/3 comma 4/3. So let's find the intercepts of this graph now. I'm going to find the y-intercept first. To do this, we're going to let x be equal to 0. So y is equal to negative 3 times 0 squared minus 2 times 0 plus 1. Y is equal to, well, all of this cancels out and we get just 1. So we know the y-intercept is the point 0 comma 1. To solve for the x-intercept, we're going to let y be equal to 0. In this case, f of x is ry. So 0 equals negative 3x squared minus 2x plus 1. And we'll solve this for x. So let's use the diamond method. If possible, we're going to take the negative 3, multiply by 1, and the negative 2 is going to go in the bottom. What multiplies to get negative 3 but add up to negative 2? That is going to be negative 3 times 1, and negative 3 plus 1 does give us negative 2. I'm going to use the AC method, so let's divide both of these by the leading coefficient, which is negative 3. And so that reduces to 1 over 1 and 1 over negative 3. Let's attach these with x's and do the bottoms up technique. So this gives us x plus 1 times the quantity negative 3x plus 1. If I solve for x, setting them both equal to 0, we get x is equal to negative 1, or x is equal to, take that 1 to the other side and divide by negative 3, we get x is equal to 1/3. So we have two x-intercepts. Our x-intercepts are negative 1 comma 0 and 1/3 comma 0. Here is our graph. We have the x-intercept is negative 1 comma 0 and 1/3 comma 0. We have our vertex negative 1/3 comma 4/3, and I can also draw the axis of symmetry to help make sure the graph is symmetric on both sides, and our y-intercept is 0 comma 1. So it's really easy to graph a quadratic if we convert it into that HK form by completing the square. Graph of a quadratic function. The quadratic function f of x equals ax squared plus bx plus c can be written as f of x equals a times x minus h squared plus k, where a is non-zero, which essentially means that we can find the vertex of a parabola by using this formula. Negative b over 2a is going to be the x-coordinate of our vertex. It's going to be the x-coordinate of our vertex. So I can use negative b over 2a, figure out what this value is, and then I can plug it in to our function to find the k or the y-coordinate of the vertex. So we can use the formula negative b over 2a to find the x-coordinate, then plug that into the original function to figure out what our y-coordinate is. Example 4. Find the axis and vertex of the parabola having the equation f of x equals 2x squared plus 4x plus 5. We could complete the square for this problem if we wanted to. Then we'll be able to find the vertex hk by completing the square. However, we want to use the formula in this case. So let's find h. H is equal to negative b divided by 2a. And b in this case is 4. So we have negative 4 divided by 2 times 2. And that gives us negative 4 over 4, or just negative 1. So I know negative 1 is the x-coordinate of my vertex. And we're going to plug this value in to the function to find the y-coordinate. F of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 plus 5. This results in 2, because negative 1 squared is just 1, minus 4 plus 5. So f of negative 1 is 3. And this tells me my vertex h comma k is equal to negative 1 comma 3. So we can find the vertex without using completing the square. The axis of symmetry is always the value of h. So in this case, the axis of symmetry is x equals negative 1.